Good evening. So today we're looking at question 10 from the common paper, the Metro Central Education Department's common paper 2021. We're on question 10, so in this video we'll cover question 10 as well as question 11, which is the bonus question. So we're on 10.1. Okay, we are told that at the restaurant 40% of the customers choose steak for the main course. Okay, so if we take that into account, then of course we have the people, the customers choosing steak, and the customers that choose anything other than steak. Okay, so if it's 40%, so 0,4 choose a steak, and then of course 0,6 would choose something other than steak. Okay, remember that those two will always add up to 1. Okay, if it was 40% and 60% will add up to 100%. I could have written that as a fraction, but I just leave it as it is. It's easier to work with. And then we are told that if 40% of the customers choose steak for the main course, if the customer chooses steak, so it's this branch, the probability that he will choose ice cream to follow as a dessert is going to be 0,6. So you've got ice cream. Choose ice cream is 0, just write this a bit bigger. So you have ice cream and not ice cream. Okay, so ice cream comes in at 0,6 and not ice cream of course is 0,4. Okay, then we are told that if it does not choose steak, which is this branch here, the probability that you will choose ice cream is 0,3. So you've got ice cream and not ice cream. So that is 0,3 and not ice cream of course is 0,7. You must find the probability that the customer picked at random will choose ice cream. So if you look at the outcomes, it's going to be steak and ice cream, steak and not ice cream, not steak and ice cream, and not steak and not ice cream. Okay, so if we look at what we need to consider, it will be, they want to know what's the probability that the customer will choose the ice cream, so it will be this branch, steak and ice cream, or not steak and ice cream. Can you see that? So if I take that into account, the probability will simply be 0,4, which is steak, times ice cream is 0,6, plus the probability that it is not steak and ice cream, so 0,6 times 0,3. So what we do is we put that into our calculator. It is simply going to be, 0,4 multiplied by 0.6 plus 0,6 times 0,3. That gives us 21/50, which is 0,42. So that is simply 0,42. Okay. Okay, now we're looking at in 10.2. We are told that in a large garden there are 7 fruit trees. Okay, just select the pen here. So in a large garden there are 7 fruit trees. As you can see, the 7 is represented there, and 13 other type of trees. 6 of the trees have birds nesting them. Okay, in total there are 6 trees that has bird nesting. Then we are told that only 2 of these trees are fruit trees. Of the 6 that has bird nests in it, 2 over them are fruit trees. The first question says copy and complete the table below to illustrate this information. So we got that information given there. So remember, it's a two-way contingency table. Okay, so 2 plus something is 6, 2 plus 4 of course. 2 plus something is 7, 2 plus 5 is 7. 4 plus something is 13. 4 plus 9 is 13. 9 plus 5 is 14. And 6 plus 14 is 20. Okay. So that's your answer to number 10.2.1. Then in 10.2.2, just change the color here. Go with blue. Okay. So here we are told in number 2, the owner of the garden has given permission for Asima to play in the garden, but has instructed her not to climb in any of the fruit or trees that has a bird's nest in them. So if the owner is cutting out the bird's nests and is cutting out the fruit trees, the only trees that are left, of course, is going to be 9 there. Okay. Asima selected a tree at random to climb. Find the probability that Asima will have followed the owner's instructions. So the owner's instruction was not to climb in a bird's nest, a tree that contains a bird's nest, or a fruit tree. So it leaves you with 9. So that answer there is going to be 9 out of 20. Remember, it's number of favorable outcomes over number of possible outcomes. Then in 10.2.3, let's change again the color here. In 10.2.3, given that Asima climbs a fruit tree, so the condition is only for fruit trees. Okay. Find the probability that the tree has a bird nesting in it. So bird nesting in that category is 2, so it's going to be 2 out of 7. Okay. So those are the answers to that question. Those questions. Okay, now we're looking at question 10.3. We are told 3 sets of twins. We have Anne and Adam, Ben and Brenda, Charles and Conrad are sitting on a bench. So we have 3 sets of twins, okay? So 6 people in total. In the first question, just select the color. In the first question, we are told in how many ways can they sit randomly, or how many ways can they be randomly seated on the bench. Okay, so if the bench seats all 6 of them, there's 1, 2, 3, 4, 5, 6. So in other words, how many options do we have here? 6. Then 5, 4, 3, 2, 1. Okay, because if the first person is sitting, we have 6 options here. 1 person is sitting, we have 5 people left, then 4, and so on. So this can be represented as 6 factorial. Okay, and 6 factorial, I think it was 720 if I'm not mistaken. Okay, 720. In number 2, we are told we are asked how many ways can they be seated if each person sits next to their twin. So if Anne and Adam is sitting together, Brenda and Ben is sitting together, and Charles and Conrad is sitting together. So Anne and Adam can sit in 2 factorial ways. Anne can sit first, or Adam can sit first. Brenda and Ben, they can interchange there, and Charles and Conrad could also interchange. However, Adam can be lying first, say in the second group, or in the third. The Adam and Anne can lie there or there. So these twins can also swap around in 3 factorial ways. Okay, just look at it again. Anne and Adam can sit there, they can sit there or there. Okay, so in other words, we have 3 placings that the twins can sit in. So it's going to be 3, 2, 1. So it's going to be 3 factorial there. Okay. So if you work that out, put in the calculator, I think the answer was 48. Okay. For those of you who doesn't know how to use that on the calculator, we say 2 factorial. You press shift, times 2 factorial times 2 factorial times 3 factorial. That gives an answer of 48. Okay, the program is lagging a bit. Okay. So in question 3, we change the color again. In question 3, we are told what's the probability if they are seated randomly that Brenda, so we have 1, 2, 3, 4, 5, 6, Brenda and Anne will sit next to each other. So that's the only condition here. So let me just move this up a bit. For them to sit together, we bind them together. Binding them together, the seating arrangement there could be 2 factorial. Either Brenda is first or Anne is first. Okay. However, they can sit at that seat, so it's 1, 2, they can sit on those 2 seats, 3, 4, 5. Can you see that? So it's having 5 placings. So it's 2 factorial times 5 factorial. Okay. So that would be 2 factorial times 5 factorial, which gives us an answer of 240 ways. I'm going to do that calculation again now, okay? Just put it here. So they want to know what's the probability if they are seated randomly that Brenda and Anne will sit next to each other. So again, there's 6 placings. 1, that's a bit deep. So it's 1, 2, 3, 4, 5, 6. Okay, so Brenda and Anne has to sit together. So what I do is I bind them. Okay, how many ways can they sit? 2 factorial ways. Okay, so now this now becomes as one bit, as one of these things. So it's 1, 2, 3, 4, 5. So I times it by 5 factorial, which gives me 240. Okay, I hope that makes sense. It's really simple. Let's look at the next question. Okay, for question 10.4, we are told in how many 5-letter word arrangements can be made from the letters of the alphabet. Now there are 26 letters in the alphabet. Okay, if the middle letter must be a vowel. Now the vowels are A, E, I, O, U. There are 5 vowels. Okay, so if you have a 5-letter combination of 5-letter word, is 1, 2, 3, 4, 5. The middle letter, that's the middle letter, has to be a vowel. So it can only be one of 5 options. Letters may be repeated. Okay, they didn't tell us that the other letters may not be vowels. That was a common made error. Okay, because then the learner selects there's 26 letters in the alphabet, then they put 21 here, 21 there, 21 there, which is wrong. Okay, because they didn't omit vowels in the other letters. So there's going to be 26 here, 26 options, 26 options, 26 and 26. So that's going to be 26 to the power of 4 times 5, which then gives us an answer of 26 to the power 4 times 5. Okay, as you can see, the calculator is lagging. So it's going to give you an answer of 2,282,880. It's 2,288,880. 2,284,000. Okay, so that is wrong again. Just delete that. 2,284,880. Okay. That brings us to the end of the paper. Okay, so now we're going to in the last question, the bonus question. Okay, so now we're on question 11.1. We are told that if n is a natural number, now natural numbers are numbers that starts at 1, 2, 3, 4 and goes all the way to infinity. Okay. We write n factorial. At this point you are exposed to factorial. We do that, we use factorial in your counting principle for the product of the first n natural numbers, so that n factorial is equal to n 1 times 2 times 3 times all the way to n minus 1 to n times n. The question says you must write log 100 factorial over 99 factorial base 10. So if we look, let me first select the color here, still on erase. If we look at log 100 factorial, so it's 100 times 99 times, okay, according to this, going the other way around. Okay, you can do it either way. I mean, we just do it the way that is given here. Okay. Okay, let's go again and read. So they're going to start at, so they start at 1, 2, 3 and goes all the way to on top 100. Okay, then sorry about that. So that would be over 99 factorial is going to be 1 times 2 times 3 times 4 all the way to 99. Remember the number prior to this is 99, then 98 and so on. Prior to that is 98 and so on. Okay, base 10. So what happens now is that 1 cancels 1, 2 cancels 2 and so on. So all of this here would cancel each other out basically. Okay, so what you have left is log 100 base 10. Now if you punch it in the calculator, you're going to get an answer of 2. Okay, but applying the log laws, that 100 can be written as 10 squared base 10. The 2 goes forward. Okay, so that will be 2 log 10 base 10, where that now gives you 2 times 1, which is 2, which makes the answer B. B was the right answer. Okay, if you're looking at the last question, question 11.2, just take this out, move it over. 11.2, we are told that C is the center of the circle and F is the point on the circle such that BCDF is a 2 centimeter by 3 centimeter rectangle. They want to know what is the area of the shaded region, that part there and this part here, in centimeters squared. So what you should note at this point is that, let's change the color here. We should note that to calculate the area of the shaded region, first it's a quarter of a circle. So it's a quarter of a circle, okay, minus the area of the rectangle. In both cases area, no? So area of quarter of a circle, how do we know it's a quarter? As you can see, it's a quarter there. and that is of course 90 degrees. Why? Because we know it's a rectangle. Okay, so it's going to be a quarter. How do you calculate the area of a circle? Is pi radius, which is r squared. Just take it out. Pi r squared minus length times breadth. We know what that pi is a constant at 3,14 number carries on there. The radius we need, the length is 2 and the breadth is 3, or vice versa there. So we need to get a radius out here. Okay, so if you look at this, we say, okay, the radius can be from center to circumference, but I'm shorting that. Center to circumference, but I'm shorting that there, PA, and here D. However, we know from center to circumference is also a radius. Can you see that? So if that is 3 and 2, I can apply Pythagoras to work out CF. So CF squared equals 2 squared plus 3 squared. That's your Pythagorean theorem. That is 4 plus 9 is 13. So CF is going to be the root of 13. It won't be plus minus because I'll be talking about length here. So your radius is root 13. Okay, so that will be 1 over 4 pi. Radius is going to be root 13 squared. I could have just written out in 13 minus length, which is 3 times your breadth, which is 2. The root of 13 squared is 13 times a quarter is 13 over 4 pi minus 3 times 2, which is 6. That is unlike terms. So your answer of course is C. Okay, I hope you enjoyed the paper, and soon you'll have the videos to paper 2. Enjoy the rest of your day.